Okay, exercise 8.3, problem 11, discussion. Let's read the problem. A spherical solid material of radius 18 cm is melted and recast into three small solid spherical spheres of different sizes. If the radii of two spheres are 2 cm and 12 cm, find the radius of the third sphere. Okay, so what's happening here is that you have a big spherical solid material whose radius is 18 cm that is melted and recast into three small spheres of 2 cm, 12 cm, and the third one is not known. That is what we are asked to find. Okay, let's first mark what is given in the problem. The radius of the bigger sphere, is 18 cm. Okay, is recast into three small solid spherical. The smaller ones, the first radius is 2 cm and the second one is 12 cm. Okay, anything else? I guess that's all about. Let's write it. So radius of the spherical solid, that is a bigger solid, that is capital R, is 18 cm. The radii of recast spheres are that R1, the first sphere, is 2 cm, R2, the second one, is 12 cm. So what are we asked to calculate? We are asked to calculate the radius of the third sphere. Find the radius of the third sphere. That's what we are asked to calculate. Now let's think. You are melting a big sphere into three small ones. So what does it mean? The volume of the big sphere will be equal to sum of all the spheres. Okay. So there is no way the material will be lost. So the material will be conserved. So whatever volume is there in this sphere will be also in all these three. So the sum of these three spheres, the volume of these three spheres will be equal to volume of the bigger sphere. Okay, that's a key point. So volume of the spherical solid equal to sum of the volume of the three recast spheres. Okay, so now let's develop it a little more. You know, volume of a sphere is 4 by 3 pi r cube. Capital R is used for the bigger, that is the original sphere, because it's big in size. So 4 by 3 pi r cube. So let R1, R2, R3 be the radius of the three spheres. So, and their volumes are 4 by 3 pi R1 cube, 4 by 3 pi R2 cube, 4 by 3 pi R3 cube. Okay. The sum of these three spheres, the volume of the sum of these three spheres will be equal to the original volume, right? The original sphere's volume. So this is how it gets equated. Now if you see, 4 by 3 can be cancelled throughout. So once you cancel, you get R cubed will be equal to R1 cube plus R2 cube plus R3 cube. So in this equation, everything is known except R3, which is the radius of the third sphere. So it can be easily calculated by substituting the values of capital R, R1 and R2. Okay. So let's summarize. Let the radius of the third sphere be R3. Equate the volume of the spherical solid to the sum of the volume of the three recast spheres. Simplify the equation and get R cubed, capital R cubed, equal to R1 cube plus R2 cube plus R3 cube. Substitute the values of capital R, R1, R2 in this equation and calculate the value of R3. And R3 is only unknown here, so it should be easily calculated. Okay, great. So pause the video here and try to work this problem on your own and come back and check your working against our solution. Okay, now we are coming to the solution part. So radius of the spherical solid R is 18 cm. The radii of the recast spheres R1 is 2 cm, R2 is 12 cm. Okay, so let the radius of the third sphere be R3. Okay, actually there is one step missing. Actually we should write first, let the radius of the three spheres be R1, R2, R3. Please write it in your notebook, and then this given should come. Okay, and this will go in that step. Okay, the radius of the third sphere is R3. So volume of the spherical solid is the sum of the volume of the three recast spheres. Okay, sum of the three spheres. You don't even need to write all this recast and everything. This volume of the three spheres, sum of the volume of the three spheres. Okay, so that is 4 by 3 pi r capital R cube will be 4 by 3 pi r1 cube plus 4 by 3 pi r2 cube plus 4 by 3 pi r3 cube. We cancel 4 by 3 pi commonly out. Okay, all the terms are there, so you can cancel it. So capital R cube will be r1 cube plus r2 cube plus r3 cube. So now we'll substitute the values of r capital R, r1, r2. Then it becomes 18 cube will be 2 cube plus 12 cubed plus r3 cube. Otherwise, this 18 cube, so we'll rewrite it. So 2 cubed is 8, 12 cubed is 1728, and r3 cubed is 18 cubed, which is 5832. So r3 cubed, you take all these things to the left side, subtract it, so you get 4096, and taking cube root, we get r equal to 16 centimeter. Thus, the radius of the third sphere is 16 centimeters. Okay. So please check your working against this, and if everything is right, okay. Otherwise, see where things are not right and correct it. If you have not understood the concept clearly, please go back to the discussion part of the video and review it. Okay, thanks for watching.